Dear students, very good morning. Today we are going to see the first problem in partial derivatives. Partial derivatives. We already seen the introduction for partial derivatives, the rules for writing partial derivatives, and the notation for writing partial derivatives and everything. So now we are going to see the first problem in partial derivatives. The problem now we are going to see is if u equal to x minus y into y minus z into z minus x, then prove that dou u by dou x plus dou u by dou y plus dou u by dou z equal to 0. So we are having u. Okay, u is given by x minus y into y minus z into z minus x. So we shall find everything separately. So dou u by dou x means partial differentiation of u with respect to x. So when we are differentiating partially with respect to x means the terms which does not involve x will act as constant. Okay, so in this term we are having x, in this term also we are having x. So both these two are function of x, but this term is not a function of x, so it will act as constant. So we are going to take it outside. Okay, into we will get what we will get, dou by dou x of x minus y into z minus x. So in this case we will get y minus z into u v dash plus v u dash. So you take this as u and this as v. So u v dash means x minus y will come as it is, x minus y into this z minus x. Here z is a constant, it will not involve the variable x. Okay, so and also in future in some occasions you may come to do like z is a function of x and y and this z will come as dou z by dou x, like that it will come. But on this problem this z purely act as another variable, because this u we have taken now is the main function, that is f of x comma y comma z. That is why we are having the z in the denominator. Okay, suppose if we are having z equal to f of x comma y means on that case this z is not a constant, it is a function. Okay, so now this is not a problem. Okay, so x minus y into z will become 0, x will become minus 1 plus this z minus x will come as it is into x, from x minus y x will become 1 and minus y will become 0, so that is 1. We can close this. So dou u by dou x equal to x minus y into y minus z into minus 1 is there, so we are taking this minus here. Minus of x minus y into y minus z plus y minus z into z minus x. Okay, always write in the order x, y, z. Okay, so that it will be easy for us to cancel. So this is our dou u by dou x. This is our dou u by dou x. Second thing is dou u by dou y. Second thing is dou u by dou y, that is equal to we have to take the term which does not involve y, that is in x minus y we are having y, in y minus z we are having y, but in z minus x we are not having y. So we can take that outside and we will get dou by dou y of what are two terms, x minus y, y minus z and z minus x. So we are having x minus y into y minus z. Okay, so that is, see, we have not considered this z minus x, so we have taken z minus x outside. So dou by dou y of x minus y into y minus z. So that is equal to z minus x into u v dash plus v dash. So x minus y into 1 then plus y minus z into minus 1. Okay, so here also we can expand it and we can write it, that is we will get, I shall bring this above. Okay, we shall write it in the above. So we shall write it above. We get this z minus x into x minus y into 1 then plus y minus z into minus 1. So that is dou u by dou y, dou u by dou y equal to x minus y into z minus x then minus y minus z into z minus x. Okay, this is your dou u by dou y. Okay, now dou u by dou z. That is equal to, you can take x minus y outside. Okay, into dou by dou z of x minus y, y minus z into z minus x. Okay, so here we are taking the positive derivative for these two products. So you have to put them inside a bracket. Now you will get x minus y into uv dash plus v dash, so y minus z into minus with respect to z, so it is plus 1 uv dash plus v dash z minus x into minus 1. So we get dou u by dou z equal to x minus y into y minus z plus, so it is not plus, it is minus x minus y into z minus x. So this is your dou u by dou z. So now we are going to add dou u by dou x. That is the question. Okay, dou u by dou x plus dou u by dou y plus dou u by dou z. We are going to add all these three. So we are going to add dou u by dou x plus dou u by dou y plus dou u by dou z, that is equal to, see, you have to write it separately. You have to write it separately, minus of x minus y, y minus z. See, minus of, you are having minus of x minus y into y minus z. Okay, then y minus z into z minus x plus y minus z into z minus x. The second term is, second we are having okay minus, okay, plus x minus y into z minus x x minus y into z minus x minus y minus z into z minus x, then plus x minus y into y minus z minus x minus y into z minus x. Okay, so now this minus of x minus y, y minus z is there, so plus x minus y into y minus z will get cancelled, plus y minus z into z minus x and minus y minus z into z minus x will get cancelled, plus x minus y into z minus x minus of x minus y into z minus x will get cancelled. So this is equal to 0. This is, okay, this, the complete value is equal to 0. Okay, so what is there? The sum becomes 0. Dou u by dou x plus dou u by dou y plus dou u by dou z equal to 0. Okay, so this is the result that we want to prove, and hence the proof. Okay, hence the hence the proof. So I hope you all understood the problem. Okay, go through this problem. This is important, and as well as this is easy also. Okay, only thing is you have to identify how to take the constant outside. Okay, and how to differentiate the remaining two terms, which are the corresponding functions. Okay, when you differentiate with respect to x means you have to consider the terms involving x. When you differentiate with respect to y means you have to consider the terms involving y. When you are differentiating with respect to z means you have to consider the terms involving z. Okay, after that you have to apply the differentiation formula, that is u dash plus v dash, and after that you are multiplying the terms, and after that you are subtracting the terms with opposite signs so that they will get cancelled, and finally you get the result as 0. Okay, so this is such an easy problem in past derivative, and moreover it is important problem also. So thank you all for watching this problem. Thank you all once again. We shall meet on some other day with a nice problem. Thank you so much.